Hello and welcome to Book Bites, a book club podcast for developers. We're going through 7 Languages in 7 Weeks by Bruce A. Tate, and this week we're going over Erlang. I'm Adam Garrett Harris.
I'm Jason Staten.
So, what do you think of Erlang?
I thought Erlang was great. Like it's been one that I have enjoyed tinkering with, and also it has really made me start to understand the arc that Bruce Tate has put us on over the course of 7 languages in 7 weeks.
Yeah.
So stopping and looking at it, seeing like Ruby being object oriented, which especially at the time that it was authored, like object oriented is kind of a familiar place for a lot of people to be in. Maybe Ruby itself was a little bit of a departure in that it was so dynamic, and IO kind of carried that along with it, the dynamic factor, but moved to more of a object oriented, like in the Alan Kay sense, like message passing. And Prolog is Prolog and like a total departure from everything comfortable, but gave exposure to the logic programming style, and then to see Scala being this bridge language, much like it is a bridge language in the object-oriented to functional programming world. It seemed like the author used it as a bridge language between like the object-oriented earlier parts of it to Erlang, which is a functional language but has Prolog roots. And so it was just kind of cool to see how the ordering of them actually played out, or has played out so far.
Yeah, definitely. And I definitely think that helped that we did Prolog before Erlang, because Erlang was originally implemented in Prolog, and you can still see those roots to Prolog.
Yeah. Yeah, I mean, the moment you open the REPL, you see it, or the moment that you try and kill it and get the same menu. So as soon as you open up the REPL and I guess try and stop it, you get actually the same looking sort of prompt as what Prolog gives you, where it gives you like the abort or debug type options when you control C it.
Yep.
And I said that's familiar.
And I was reading more into the REPL, and it said that Erlang's REPL has its own built-in line reader, which is very similar to Emacs. And so you can use a lot of the same keyboard shortcuts to get to the beginning of the line is Control A, and I think end of line is Control E, and things like that.
Yeah, I noticed that. I used it a couple of times. I was a little bit disappointed that it wasn't using readline, because readline you can turn on VI mode. Yeah.
Nope, it's just using its own built-in thing that's kind of like Emacs mode and readline.
Yeah. I alongside actually reading 7 languages, I spent a little bit of time going through the Learn You Some Erlang book.
Yeah, I did too.
And I think it was in that book. Maybe it was even some other resource. They had a couple of things that they recommended for adding as an environment variable before starting up your Erlang shell. One lets you have history get preserved. So if you start it, and if you restart it, then you can have your old historical stuff. And
does that include values of variables?
So it doesn't restore the state, just all of the commands that you executed, kind of like bash history or something.
Okay. Yeah. In Learn You Some Erlang for Great Good, it said that sometimes you might actually have a Erlang REPL running for a really long time, for years, and it provides a backdoor, because normally in Erlang you can't reassign a variable. It's not really called assigning, right? It's called matching, but they provide a backdoor or an escape hatch in the REPL where you can run a function called f, I think, that erases the value of a variable.
Interesting. I didn't actually go over that. I did a good amount of skimming through Learn You Some Erlang for Great Good. So
Yeah,
I
so that
missed
can be
that
really
one, but
useful if you're playing around on the REPL a lot and you're like, crap, I wrote that wrong, and instead of having to come up with a new variable name to run it again, you can clear it.
interesting. I dig it,
Yeah.
but probably not on a production process that's been running for years. That
Yeah.
may be a little bit dangerous.
You can't do it in real code. It just works in the REPL.
I see. That makes more sense.
So I spent about the same amount of time on this chapter as all the other chapters, about 4.5 hours, and
Yeah.
about 2 hours and 45 minutes of that was just reading, and then the rest was exercises. And I probably could have spent a lot more time on exercises. And I guess there was also some other time I spent on Learn You Some Erlang that I didn't count.
Mm-hmm.
But how was the installation process for you?
I believe that I just brew installed it.
Okay. For me, it was already installed. I'm not sure
Interesting.
why or how.
Hmm.
If you had to brew install it, I was assuming it just came installed on Mac, because I don't remember ever installing it before.
I guess, I mean, one decent way of finding out is doing a witch on it. Like if you just did a witch on Earl, then if it's in user local, then it's probably a brew thing.
It's user local bin, yeah.
Yeah. So I don't know, maybe something else depended on it.
Yeah, maybe. But either way, it was really easy. So
Yeah.
last time I got a little hung up with Scala where I wasn't using the right text editor or IDE. What did you use for Erlang?
Once again, I opted for VS Code, and once again, it actually worked out pretty well. There is an extension that is, I think it was just Erlang, is what I went and grabbed. But
Okay.
It had both syntax highlighting as well as like it would call you out for like compiler type errors or warnings. So if you were doing something you shouldn't, you got the squiggly. And what was really nice is when you were calling on any of the standard modules, it would give you like a brief documentation of them as well.
Oh, nice.
Yeah.
Yeah, so I just used NeoVim, and just right out of the box, whatever plugins I already have installed, it worked really well. Syntax highlighting worked, and I got this squiggly next to the line that had an error, and it would tell me what the error is.
Yeah.
So yeah, that worked out
Nice.
pretty well.
Yeah, it's definitely good to have that sort of feedback when you're working with something new, to be like, oh, that's
Yeah.
what the syntax is, or like any bit of fast feedback, I think speeds up the learning process.
Yeah, especially since to run it, you have to go into the REPL, compile it, and then try running it.
Mm-hmm.
You don't want that to be the first time you find out about an error. That's too slow of a feedback loop.
Yeah, I would definitely agree.
All right, so what about day one?
Day one was pretty refreshing for me to go through, like using an actual functional language. In that, I guess actual, that's probably like a crude comment, but more so like one that meets what I think of with a functional language, one that you maybe go and define a function multiple times with different patterns to go and match against. Like that's what I think about with things like Haskell or OCaml, and Erlang was definitely in that same sort of camp where it's got the pattern matching that you can go and do when you define a function to say this is a function that applies for the pattern of an empty list, like give back the value of 0, and anything else like go and take the head of it off, like destructure off the head, and then do something with the tail. So if you're doing like recursion, it makes it pretty nice to use, or like easy to go and add like a clear base case without having to add an if type conditional in there.
Yeah, it reminded me a lot of a prologue, and that's probably the first time I saw it where you would write a function multiple times with the same name, and one of them has a base case and different different versions of it match different things.
Yeah. I think while it is in some ways more verbose than having an if, I feel like I don't know. I mean, it's definitely still branching, but it doesn't feel like it as much.
Yeah.
If that makes sense.
Yeah. So it talks a little bit about the history too in day one, that it was based on Prolog, and I kind of got the idea that it was like a fork of Prolog, but I don't know if it was a fork of Prolog or they used Prolog to create Erlang. But that was back in 1986, and now it's not implemented in Prolog anymore. I'm not sure what it's implemented in now, but that's its history, because the guy who made it was using Prolog and he needed something that supported concurrency really well.
Yeah. I mean, it sounded like he wrote a Prolog meta interpreter that added parallel processes to Prolog.
Wow.
And I mean, I guess I could see the rationale in that. I mean, in trying to go and support like a telecom type system.
Yeah, and it said some of these Erlang systems have been continuously running for years because Erlang supports code hot swapping.
Mm-hmm.
I'm not sure exactly how Erlang supports that or how that works exactly, or like I don't understand how that's a feature of the language rather than how you're deploying it or something.
Well, I guess the big thing is that it's not like you're shutting down the process, like the process being like you're not shutting down the VM to go and add new code and then starting up the VM again.
Okay, so you could just replace a file of code.
Yeah, so go and replace a module,
and it doesn't crash the program.
Right. I mean, you can even see it just as simple as inside of your REPL. Like you could go and compile the same module over and over, and it's fine with you doing that.
Okay.
You don't have to go and shut it down and start up another one. And they have a bit about it in Learn You Some Erlang, where there's a section called Hot Code Loving, and
what?
Yeah.
I really appreciate how Learn You Some Erlang is written. It's very easy to read and it's fun.
Mm-hmm. Yeah, it was definitely like a nice deep dive, like accessory deep dive on top of this.
Yeah.
Like 7 Languages has done a great job of giving like the whirlwind tour. Like that's its whole purpose. But like,
yeah,
if you wanted to go further, like I wouldn't hesitate to go and recommend that. But they talk about it playing out as a good option because of when you create an actor or a separate process that's running in its receive loop.
Okay, yeah. So we just jumped all the way to day 3 basically, which is all about concurrency.
Yes.
But anyway, go on.
Yeah. So I mean, without going too far on it, but given that you have the actor, the separate lightweight process, like if you go and hot load code, like, it's that process alone that's able to go and start its new version of itself. And so it's basically just receiving a message that says, hey, you're now a new version of this process. and like it has to go and handle like migration of its current state. So it receives like its previous state being maybe a list or something and upgrading it to whatever the latest version needs. Like if that signature changed or something.
Wow. Okay, cool.
Yeah. So, the syntax, while, like it took a little bit to get through, like it's also like relatively, straightforward for me, or was all right for me to go and pick up, like that your function bodies, like they end each statement with a comma, which reminded me of Prolog. And, because in Prolog, like your kind of separate statements within a function were comma separated. A major difference being that represented some condition that had to be met met, so it was like an and in that case.
Yeah, yeah.
But then when you're done, you actually go and drop a period at the end of your function, or to say like that's it.
Yeah.
So it's like a sentence.
Like a sentence, exactly. Yeah,
The-
very, very similar to Prolog. You have variables that start with a uppercase letter.
Mhm.
You have atoms, ATOM,
Mhm.
atoms that start with a lowercase letter, and they just are what they are. They don't have a value associated with them. And then you can use an underscore for matching something you don't care about. And what I didn't realize is you can use an underscore and then actually have some letters after the underscore. And that's if you just feel the need to name this thing that you don't care about.
Mhm.
I guess it's kind of like
Kind
a
of
comment, like
Documentation.
underscore tail, but I don't actually care what the value of tail is.
Right.
Yeah, it's like documentation.
That is kind of a unique bit.
Yeah.
So, self-study. How did that go over for you?
Let's see. For day one,
Yeah, it was like find the number of words in a string.
I did the first one. So I did that one.
Yeah.
Let me look at it real quick. Oh, I've got it right here. So what tripped me up is that I tried to do it all with one function, and then I actually ended up doing it with two functions once I kind of saw how other people did it. So one of them counts. Let's see. So they both use arrays. Is your implementation using arrays?
Oh, to count the words.
Yeah.
Yeah. I mean, mine. I guess I wasn't using arrays. I was using a list.
Oh, sorry. Yes, that's what I meant a list.
Okay. Yes.
Yeah, so I have one function called num, and if it's an empty array, it just returns 0. If it's something else, then it calls count with the sentence and the number 1 as the initial count.
Mm-hmm.
And then for count, if it receives an array, then it just returns count. If it's an empty array, it just returns count.
Right.
And then what was really weird is that if the head of the list, and I keep saying array, sorry, it's a list. If the head of the list is 32, which is apparently how you represent a space, then call count again with incrementing the number by 1.
If it's
anything else, if it's anything else, just call count again with the same number.
Huh. So, yeah, mine was all just through like a set of pattern matching on count that I defined that said if you have a tail and should I kept a flag that was passed as an argument of whether you should count this or not, and the flag got set to true every time I encountered a space, and anytime it matched and that flag was set to true, then it would add 1 to the total. And I went and tried to make it made it tail recursive as well, so it's shouldn't blow the stack. So
yeah. So it looks like you use count, but with 2 different arities.
yes. Yeah.
So initially you have count. I'm guessing you're exporting count /1.
Yeah. Yeah. So I had count that just takes in a string. So yeah, count of arity 1. It was kind of my public facing API of the module.
Yeah.
And then internally I had a looping one that was recursive that actually had an arity of 3 to hold the various states. Firstly, the remainder of the string. Secondly was the flag of whether or not to increment the count. And thirdly, to keep track of the total.
Yeah. Cool.
Yeah.
And then I skipped out on the rest of the homework.
Oh, for
day 1.
Recursion to count to 10?
Yeah, recursion to count to 10. I'm assuming that means that you're printing out the numbers 1 through 10.
I just built up a list.
Oh, okay.
I mean, I guess printing could have worked.
It doesn't specify how you count.
Nope. So it just like I guess a classic interview question. Like they didn't define it, and given I couldn't ask,
Yeah.
it just chose my own path on that. So yeah, that's just appending to the head, and
The next one is like a sorry. Go ahead.
So it uses Erlang's syntax for going and creating an array like with a head and a existing list. So like concatenating to the front. So it's like the square brackets with whatever you want to put on the head with the pipe, and then whatever tail that is another list.
Oh yeah, that reminds me. So this is similar to the syntax in Prolog, where you can pull off the head and the tail. But in Learn You Some Erlang, they had a really great illustration talking about this concept. And over Thanksgiving break, I was reading it, and my son and nephew came up and saw the picture, and it was pretty funny because it has a picture of a snake, and and the snake has a mustache and a face, and it says, this part is the head, everything else is the tail. And then it shows a picture of you cut off the head, and then it like draws on a new head, draws on a new face on the cut off part. And now
Nice.
This is the head, and everything else is the tail.
I dig it.
Yeah. And then when you get down to just one item, the head is the one item, and the tail is an empty list.
Yeah. Yep. So did that. It was pretty straightforward, and even the third one was just a matter of doing a bit more pattern matching. I find the way that they approach structuring messages kind of interesting, where it's often a tuple with an
atom.
No, so a tuple with an atom at the start, and then after that it's just the additional fields if there are any.
Yeah.
So they use pattern matching to say, oh well, this tuple is success, and there is no message, therefore do nothing, or sorry, therefore don't try and read the message. But if it is a tuple that has error at the start, then bind the variable message to the second item within the tuple.
Yeah, there was an example later on where there was a tuple, and the first value is an atom that says Celsius or Fahrenheit or Kelvin. Wait, is that right? Kelvin? And then
Kelvin,
the second value is a number of degrees. And so then you can pattern match on that and say, if there's a tuple and the first value is the atom Celsius, then you know what the value is, what format the value's in.
Mm-hmm. Yeah.
So that's
kind of a
pretty cool.
Cool way of dealing with various types of input while not being a statically typed language.
Yeah. So it's dynamically typed. It has some type coercion, but it doesn't do like int to string, for example.
Right. It is a part of the language now to allow having type specs for your functions.
Interesting.
So if you just within your code add like -spec, just like -module or -export, like those types of directives.
Oh, okay.
You can go and use that as a way to annotate your functions, and then Erlang has a built-in tool called dialyzer that can go and do a limited level of type checking.
Interesting. So it feels kind of like TypeScript is to JavaScript or Flow compared to JavaScript, where you
just kind
with Flow you just add a comment to the top of your file, annotate the types inside of comments, I think. So it's not actually, it's still valid JavaScript.
Mm-hmm. Yeah, and I don't think that the specs are like enforced by Erlang's compiler so much as the additional dialyzer tool on top of it.
Okay. Yeah.
So it's not like you're going to fail compilation, and instead it's just some additional benefit there. And I believe that it can get used in like documentation generation. So then you can be like, oh, well, this is the typing of whatever this is, as well as like nice, like your docs benefit as well as your code consumers can benefit from having definitions. So
yeah,
I dig that.
Yeah. Another interesting thing is bit matching.
Mm-hmm.
So on the binary level, you can match certain bits. I'm not exactly sure why you would want to do that.
So some of it is that you don't always need to operate in full bytes, and it kind of lends itself well to the period of time that this was written for, or like the purpose that it was written for is really high efficiency.
Yeah.
I mean, you can see that in a handful of things that Erlang does, is that it's trying to be efficient in the places that it can. I mean, like with the tuple structures being like, I mean, it's not key value of like type is error and message is message. Like,
yeah.
Instead, it's just positional. And so, seeing it with the bit operator stuff, like sometimes you just don't need the entire byte, and that's really common in things like network protocols as well, where sometimes you'll get a byte's worth of information over the wire, but the first bit is indicative of like, is this the first frame in something, or is it like a continuation of something else? Like,
right.
So I don't know. I think of more network protocol stuff.
Okay. Did you figure out what beam is? Because so with Erlang, you compile it. You have a .erl file. You compile it,
mm-hmm.
and then you end up with a .beam file.
Yeah. So I mean, beam is the name of the Erlang virtual machine.
Okay.
And so the .beam file is the byte code that the Erlang VM knows how to run. So it's what it can load. Much like if you are compiling Java, you wind up getting the class files out that are a intermediate type representation that the VM can use.
Okay. Cool.
Yeah.
So, yeah, I think it said something like the beam files are run by the beam. And you just compile it with C parentheses file name.
Mm-hmm.
Period. I always forget the period in the REPL. If you forget the period, it doesn't do anything when you hit enter. And you can type a bunch of more stuff, and it just doesn't do anything until you hit period enter.
Yep.
And then it's probably garbage at that point because I've typed a whole bunch of commands that don't make any sense all strung together.
Yep. But you can at least put it, like, if you forget, which I do plenty of times, if you haven't typed anything yet, you can just put period and it will be cool with that. So. Yeah.
So one really good thing from the introduction of Learn You Some Erlang, it said it was talking about concurrency and actors, which it mentioned in the introduction because it's such a big part of Erlang.
Mm-hmm.
And to explain actors, it said if you were an actor in Erlang's world, you would be a lonely person sitting in a dark room with no window, waiting by your mailbox to get a message. Once you get a message, you react to it in a specific way. You either pay the bills when receiving them, you respond to birthday cards with a thank you letter, and you just ignore the letters you can't understand.
Yep.
And I thought that was such a cool way to think about it.
I mean, one thing that's nice to know is that people at least can find out if you die too. So and do something about it. Like you can be brought back, or a copy of you can.
Yeah. So I don't know if we just want to skip over day 2. Is there anything you want to talk about day 2 before we go to day 3?
Well, I mean, it talks a bit about list, and they had you work with they said keyword value tuples.
Right. Okay.
And that was one thing that I was even just curious about in the language, like how to deal with like a key value type lookup. And I said, my thought is like, is that the best you've got?
Is that the best? Yeah.
Like just having a list with a whole bunch of tuples in it. And it turns out, like, firstly, Erlang has a library for working with structures like that are called prop lists.
Oh, okay.
And the thing that they actually...
It's the kind of tuples we were talking about earlier, right? Like the Celsius Fahrenheit example.
So it is, I guess, a prop list is a list that are full of those tuples.
Right, okay.
And a prop list is not like a fully defined thing. Like, you don't go and, like, there is no prop list : like add or append type function that exists. Like, they just assume that you'll go and tack it onto the list in whatever way you prefer, like sticking on the head just through normal means, because it's just a list of a specific structure. But
and lists can contain any type, mixed types inside of it, right? So it's just kind of convention that you would put a certain type of thing in a prop list.
Right. And so, like, that's what prop lists just assume, is that that's what you're going to give them. But it does turn out that Erlang does have a number of different data structures in it. Like, it does have things like sets, and it's got sets and dicts, like dictionaries, and there are, I guess there are a couple types of sets, and this unique thing that is for working with Erlang's common structure, like we talked about the tuples before, where you have like the tag at the start of it saying like success and then some message after it.
Yeah.
Erlang has this thing, the notion of a record. And a record is something you can define within your module, like close to the top, using the -record directive. And you give that an atom of whatever you want to call the record, and then you give it what kind of looks like a tuple of your I guess kind of the name of your keys. So if you wanted to have kind of a key value structure that that you could pull values out of, record would be a way to do it. But what's interesting about it is records are really just represented as a tuple with that atom at the start and all the other stuff positional. But you can go, and when you're creating one, you can assign stuff in whatever order, and the compiler will go and put it in the correct defined order. And records are only applied to a given module, or they're only available within a module that has it defined for it. All outside consumers just see a tuple. So it can be kind of like an API that you use internally, but you don't have to expose unless you choose to.
Okay.
But anybody else can just consume it like in a normal way. Like, it's not a specialized structure, which is cool. It's more like a hack that's bolted on.
Yeah. I was just looking here in Learn You Some Erlang, and it says it's a hack. It was a afterthought to the language. But yeah, still looks really useful.
Yeah, it's kind of nice for adding some clarity of like, what is this thing? It is kind of ugly in that you have to anytime you want to access a field as if it were from a record, you have to put like hash whatever the name of the record is, and then say you can do like dot. So I had like the notion of like race car drivers, and so I had a variable d, and then I had to do like hash driver dot fastest time in order to go and access it. And so like you do have a bit of that, but it's cool that they have it, and that it's not like a separate type.
Yeah.
And also they do actually have a map in Erlang as well. So if you just put like hash and then curly braces, you can go and do key value using the arrow, using like the equals greater than for to say key points to value.
So it actually has a map data type?
Yes. Yeah, it is a new thing in Erlang. And you can do things like pattern matching off of it to go and extract known keys and stuff.
Okay, cool.
Yeah.
Yeah, for a second there, I thought you were talking about mapping over a list.
Oh, yeah, sorry. But actual, like, I don't know if you call it a hash map, but like a key value type called a map.
Yeah,
And
map, similar to the dictionary.
Mm-hmm. That's been one thing I have liked about going through this book now, is seeing like how some of the languages have evolved over time. And this thing is one in particular that is a kind of unique change, because doing the prop list is probably it's not something you would maybe reach for quite as much. I mean, I'm sure there's still good justification for it in some cases, but if you have an actual key value lookup, maybe that's worth considering over it.
Mm-hmm. Yeah. Let's see. Yeah, and it talks about a lot of functions on list: for each, map, filter, all, any, take while, drop while, and then it has fold L, which took me a minute to realize is just a reduce.
Yep.
But thinking of it as folding from the left is an interesting way of thinking of a reduce. That you have some sort of initial value, and as you look at each value in the list, you're kind of folding it in to that one value.
Yeah. I think it is a unique way of looking at it. I mean, I tend to think of it like crumpling a ball into a singular value, but
yeah.
Okay.
And then it talks about list comprehensions.
Oh yeah.
So
have you worked in a language with list comprehensions before?
No, I'd never heard this term before. Have you?
Yes, I have.
Okay.
So
let me see if I can explain it.
Yeah.
It's this interesting syntax where you can list out several different conditions actually. But the main one that you'll have is a list with a left arrow on the left side of it, and it goes from a list to some variable name, I guess. So it's going to map over that and go to that variable name, and then to the left of that you have two pipes, and to the left of that you have an expression, and that expression is what you do with that variable. But you can have multiple conditions. So, I mean, a very simple example is something you can do with a map, where you just, the expression is like n+1, and then you'll get a new list where each item is +1. But there you can also add in another condition that just says n has to be greater than 5. So at the same time, you're also filtering out numbers that are less than 5. And then you can go even crazier, and you can have another list go to some variable, and then your expression can be combining those two things together, and then you end up with every combination of those two things.
Mm-hmm. That kind of nails it for me. It is a I don't know, multi-use syntactic tool for doing maps, filters, and combinations.
Yeah.
And yeah, I've used it in the past, and it's kind of nice, like not having to go and make a chain of map and filter, because a lot of times that's pretty common to do, is like change the structure and pull, like, but only take things that hit a certain criteria out. So
and you also, I guess, with the list comprehension, you don't have to think about what order you're doing those things in. Do you map first and then reduce, and then filter, or do you filter first and then map?
Yeah, that's true. Definitely more on the declarative end.
Right. And I already feel like map and filter are more declarative than doing a for loop.
Mm-hmm.
But this is even more declarative, which is nice.
Yeah, you definitely, like, you end in saying, this is what I want to come out of it. And
right, I forgot to mention the whole thing is surrounded with square brackets.
Right.
So you're starting off by saying, I want a list.
Yeah, and that even helps make it clear to the reader of the code, of like, this is still a list that you're going to get.
Yeah. Okay, what about day 2 self-study?
Day 2 self-study. yeah, I went through that one, did the lookup, and that's how I found out about the prop list get value, and so I just recursively went over until I found a pattern match of the key that matched a tuple with that key. So what is kind of cool is that if your function takes an argument and you bind it to a variable, you can also assert that same variable matches within a tuple, and that works, which is pretty. I wasn't sure if that would actually work out, but it did, and it was kind of nice. There.
Yeah, I loved this first one. Okay, so the first one you take in what did you call the keyword value tuple? A prop?
Oh, prop list.
A prop list.
Or yes, prop list.
Yeah, so you take in a prop list that has an atom of the language name, and the type of language is a string for the second value, and write a function that accepts that list. And let's see.
So yeah, mine was just 4 patterns. So I said if it was an empty list, like I don't care about the key. I just said that it was unknown, and then I would say like if it is one that matches the key that I passed in, like if it is a prop list that happens to match the key that I passed in, then read the value from it. If it is a prop list that happens to have a tail, because the first assertion already happens, or for the first patterns there, like if I have a list that's remaining, like that has a remaining tail on it, then just try and match the key against the tail. And then I wrote a 4th one because I was playing with maps to make it work again. Like the same behavior will actually work against a map as well, to say if you're trying to map against something that is a map, then use maps get key instead.
Okay. Yeah, so the function accepts the list and a keyword, returns the value for the keyword. Yep. I did it with 2 lines of code, and
nice.
Yeah, it's really nice. I won't bother trying to explain it because it's hard to explain with audio and hard to listen to someone explain it with audio. But we'll have links to all of our code in the show notes.
Definitely. All right, let's hear about day 3.
Day 3 is all about concurrency, which we've talked about already because it's hard to talk about Erlang and not talk about concurrency.
Yeah.
But actually getting into it, I found harder than just the idea that Erlang is good at it. So I went through and typed out the examples, and it was cool and made sense. And also the examples are kind of they just don't feel like real world examples. So it's still kind of hard for me to wrap my head around how you would use this in the real world.
Yeah, I think that's the case where Learn You Some Erlang tries to spend more time on actually like thinking about how to build an application out, like how to think about organizing your application. And I mean, I definitely didn't have time to get through all of it, but I mean, in short, it was I mean, you can go and take any function of any module and pass it to the spawn built in, and if you go and choose to do that, then you can you end up getting a process ID or a PID back, and with that you can send a message to it using the exclamation syntax or the bang, which is just like what Scala has, or I suppose Scala is just what this has.
Yeah.
I see the inspiration there, or like the carryover. And when you do that, if the function within the other module that you called has a receive on it, then that receive will get called, and you can kind of do a pattern match against whatever you do receive.
Okay.
And I think it's kind of cool that you can just go and have any function go and receive as if it was an actor. Like there's not a lot of ceremony in terms of setting that up, and even the fact that like the thing just can get repeatedly called, and the function can get repeatedly called only if it is like recursively looping on itself, because Erlang doesn't have the notion of like a while loop or for loop or something. Like you actually have to call the function again, and if you want to have the actor maintain state of some sort, you have to recurse passing the state in, or the modified state. Like if you're whatever you receive needs to modify your state, modifying being like replacing it.
Oh, okay. Yeah, okay. I didn't entirely catch that, but the example here, they make a function called loop, and it receives a message. It does some pattern matching on it, and then after each message that it matches, it just calls loop.
Yep. And if you don't call loop, then it will stop. Like it will wait for the message to be received, and after it receives it, it will no longer loop anymore because it didn't call itself.
Yep.
And then on top of just being able to go and spawn a message, you can spawn an actor and send it a message. You can receive back from it simply by in your current process calling receive. Then it sits and blocks that process, waiting on a message to get received. And the way that you say I want to get called is if you've ever I don't know, like gotten stickers from someplace where you have to send like a self-addressed envelope.
Yeah.
It's very much like that. Or you say, here's where I'm at. I mean, stamps on it and everything. Like when you do what you want to do, like call me back right here.
So that really makes sense for an actor sitting in an empty room with just a mailbox. You open the letter. There's a letter inside of it. Just stick your message back in there and put the envelope back in your mailbox.
Mm-hmm. Yeah, you don't particularly care who it came from. You have a way of sending that back to them.
Yeah.
And so that is the way to respond.
I guess it works that way with any letter, really, because you've got a return address. But how does it work in Erlang? How does it know where to send it back?
So you can actually get the process ID of yourself, and they gave an example of it in the book where it is a function that you call that is self.
Oh, okay.
Like self 0 arguments, and that will get the process ID of your current running process so you can send it over the wire to somebody else to say this is my address or this is who I am.
Yeah, cool.
And then I mean it branches out to not only being able to just spawn something else, but being able to spawn linked. And
yeah, what does it mean for it to be linked?
So when something is linked, then or like when you link, you can get awareness of what happened to that other actor. So like if it goes down, for example, then like if that actor dies, then it can notify, or it I mean basically it will send a message to whatever it's linked to. So say my process A, or like my top level process, is running and it spawns process B in a linked fashion, then if B exits for any reason, then it will go and send a message back to the originator.
Okay. Yeah.
And so that allows like A to make the decision, like, do I go and start another one? Do I do I don't know, some other type of behavior? Like, do I store the fact that went down in the database? Like, it gives like supervision as an option.
Yeah.
And Learn You Some Erlang talks about like, while like spawn and spawn linked are the primitives that you start with to learn about it, you from the OTP library, the what is OPT? Open Telecom Platform. That is the acronym for it. They have supervisors that they provide for you that can give you more complex handling of failures.
Okay.
So, I don't know, like different strategies.
OTP is definitely worth mentioning because when you start searching for Erlang, you see Erlang/OTP all over the place.
Mm-hmm.
And it's like OTP is a library for Erlang, but it's almost part of the language itself at this point. I'm not sure exactly what the relationship is there.
I mean, in some sense, you could kind of think about like Node, like V8, for example, is the JavaScript engine that Node runs on top of. But when people write Node.js, like a lot of times people say they write Node.js, where they are writing the language JavaScript, but they're using all of those established built-ins that come with it.
Yeah.
I mean, OTP in a similar fashion is like what you use in order to actually get stuff done.
Yeah.
So that it's the same sort of thing, and you get like the supervisors that can monitor multiple child processes, and I don't know, they have a few different strategies that are kind of cool that exist. Like there's one for one, so like if a child process dies, then it just starts it back up.
Yeah, that's very cool.
Like unless it happens so many times, at which point it'll say nope, you don't get to start anymore, and instead take some other behavior. And there's also like the one for all, so like if a child process goes down, kill all of the other supervised processes. Which I mean, I'm sure there are cases for that. It's like, okay, like these were meant to work together. Say like you have 3 child processes that are all intercommunicating with each other, and one of them goes down. If that happens to put the other 2 in a bad state, or could put them in a bad state, then send the shutdown to the other 2 to say, you're gonna, like, you need to stop. and then they even have like other ones too, that it's like based on the order that they were started supervising, go and kill like all the remainders of them. So like it's like kill the tail and then restart it.
Okay.
And I don't know, all those things are definitely like they're built-in things that you can go and hinge on. I mean, you get a glimpse in here of like the low-level primitives of it, but you may not necessarily be using them directly all the time. Just kind of being aware of them, though, helps you understand that you can get an opportunity to respond or handle the failure of some other process that you are linked to.
Okay. Yep. Sounds good.
Yeah. So I guess in terms of things, would you see yourself ever writing Erlang?
Possibly. Let's see, out of the languages so far, I could see myself writing Ruby, Scala, and Erlang. But yeah, what about you?
I would say that with Erlang, it's been probably the language that I have enjoyed, or it has excited me most thus far. I mean, Prolog was definitely the most mind-bending, but hard to see like the practical in it as much as Erlang, especially in like our highly concurrent world that we're in, where we have 64 core CPUs that are like readily available, and so like and Erlang is something that totally benefits from that because of its constructs. I would say I really liked it as a language. I am very curious now to take a look at Elixir, which is a different syntax for Erlang, or like an Erlang compatible language built on top of the Beam still.
Oh, interesting. Yeah, I could definitely see myself using Elixir more likely than Erlang. And yeah, I would probably only use Erlang if I needed to write a really reliable concurrent system, which I don't see myself needing to do.
Yeah. I guess if you're doing Elixir though, you still get OTP just as well. Either one you opted for, but Elixir kind of gives you more of a Ruby inspired syntax on it.
Okay.
And So like you use, I don't know, kind of the def and do and end type phrasing rather than semicolons and periods to go
and
into
commas.
Things. Yeah. So a bit different, and I still haven't spent a whole lot of time with it, but that is a place that I would like to dig in more because it was kind of a fun experience to get into Erlang and see where it's going. I'm actually using it right now for going through the Advent of Code 2019, the coding challenges, where every day they have a new coding challenge, kind of in the same fashion as Project Euler.
Yeah.
Where you have a problem to solve, and I guess in this case, like, you get an input list that you have to work from, and then you ultimately have to produce a single value that you hand back to them.
Are you submitting your code online and then they run it against unit tests?
So it's not one that you submit your code. You can use any code to solve it. You just have to produce the answer.
Okay.
And you as a user get a unique input. So if you have if you happened to steal my answer, like, it wouldn't work for you as a user. You would have to know my code.
Very cool.
Yeah.
Well, next week we'll be going over Clojure. I don't know how to pronounce it. Clojure.
Yeah.
And Clojure is compared to Yoda. I forgot to mention this week that Erlang was Agent Smith, but yeah.
Yeah. Well, I look forward to doing that. I have a little bit of experience in the past with Clojure.
Sounds like the syntax is going to be a little backwards.
Yes. I mean, well, definitely a departure there. So once you get your head around that, though, it's definitely an inspiring language. So I'm looking forward to it.
Yeah. Well, right. You can follow us on Twitter. I'm at Agarhar. Jason is at Staten Jason. The show is at BookBites FM. If you haven't already, please leave us a review in iTunes. It helps people find the show. And we'll see you next week.
Later.
Later.